Hello, mathematicians. Today we're going to be learning about slope-intercept form. So slope-intercept form is represented by the equation y equals mx plus b. And m in our equation represents our slope, which we also know as our rate of change. So we also know our slope as our rise over run, which I'll get more into in the video. And in our equation, b, our variable b, represents our y-intercept, which is where the line crosses the y-axis, at 0, b, which is the value that our line crosses the y-axis. So we previously know our y-intercept as our initial value. So here we have an example. A plumber charges $40 plus $60 per hour of service. So here our $40 that were charged initially is our initial value, which we also know as our y-intercept. And then here our charge of $60 per hour is our rate of change, because we're being charged $60 for every hour, which we now know as our slope. And so if we're writing an equation in y in a slope-intercept form, we're going to start off with y equals, and y in this case represents the cost, and then we have m, which is our slope, our $60 per hour. X, because we don't know the number of hours, plus $40 because that's our initial charge. So the 60 here represents the cost per hour, and the 40 here represents our y-intercept, so the charge before any services. And just keep in mind that our 60 here is our rate, because we're being charged that $60 per hour, and we don't know the number of hours, so we're going to multiply our rate by the number of hours plus the $40 initial fee charge. So here, instead of writing 60 over 1, we could just leave it as 60, but just be mindful that that's our rate. And so now that we have our equation here, we can make a table and we could graph. So in our table, we're going to represent the relationship between our x and our y value. So our x value is our hours. And our y value is the cost. And so if we have the plumber for 0 hours, just be mindful that there is an initial cost of $40. So before the plumber even starts working, there is a charge of $40. After 1 hour, the charge will increase by $60, so it'll be the $40 plus $60, which is $100. And then after another hour, there'll be another increase of $60, so $160. And then again, and this will just continue to increase. So if we look at our chart, our table here real quick, we'll notice that there is a continuous increase of $60 every time the hours increase. Because that's our rate, okay? And so if we were to graph this, we'd start off with the initial charge. So before any hours passed, we'll start off at 40. And then after 1 hour, the charge will be $100. And then 2 hours, $160. And then 3 hours, it will be at $220, and so on. So if you notice, as we plot our points, you will see that there is a pattern. So from this coordinate to here, we went up 3 boxes over 1. We went up 3 units over 1, up 3 units over 1, and so forth. So the 3 units that we went up, for example, if we look at these 2 points, every box represents $20. So 1 unit is 20, 40, and then 60. So we're actually going up $60 for every hour. And I'll show you guys what that looks like in a little bit. So I'm just going to draw our line here. And so what I was saying before is if we connected any 2 points, so let's say these 2, you'll notice we went up 3 units, and these 3 units represent the $60 per hour. Okay, so this is why our slope is also known as our rise over run, because from this coordinate to this coordinate, we're rising up $60 every hour. And even if you pick 2 different coordinates, let's say this one and this one over here, now we're going up by 6 units. So 20, 40, 60, 80, 100, and 120. So 120. And this is 2 because our x is increasing by 1. And $120 in 2 hours is equivalent to $60 per 1 hour. So no matter what 2 points we pick, we'll always get our slope. Okay, so on our graph, this is our y-intercept. Which is at 0.40. And our slope we could find using any 2 points by making a triangle, finding out how much will we increase from this point to this point, and then how much we increased from side to side so that we could find our rise over run. So 120 is how much we went up from this point to this point, and then 2, it represents the 2 hours, represents how much we run from this point to this point. So we could use any 2 points to find our slope, and our y-intercept is where this line crosses the y-axis here, otherwise known as our initial value. And that's it. So here we have another problem, and it reads, John's plant is 6 centimeters tall and grows a centimeter every 2 weeks. So again, if his plant is 6 centimeters tall, this is our y-intercept because it's our initial value. And if it grows a centimeter every 2 weeks, this whole line here is our slope. And I'll show you what I mean by that. So in order to represent this in slope-intercept form, we're going to write out y equals, and our slope here is 1 centimeter every 2 weeks. So our rate here would be 1 centimeter every 2 weeks. And that's why we have half. Since if it's 1 centimeter every 2 weeks, then it's half a centimeter per week. So a half x plus our initial value of 6 centimeters. So if we made a table, we would have our x value as our weeks, and then centimeters as our y. And so here we'd write the number of weeks. And before any weeks have gone by, our plant is 6 centimeters. And then after 1 week, the plant is now at 6.5 centimeters. After 2 weeks, it'll be at 7. 3 weeks, it'll be at 7.5. So 7.5. And that's because our plant is growing 0.5 centimeter every week. Now, if I did want to represent a centimeter every 2 weeks, what we could also do is write out, so instead of counting up by 1 week at a time, we could count up by 2 weeks at a time. So after 2 weeks, the plant grows 1 centimeter, so 7. After another 2 weeks, it grows 1 centimeter, so 8. And then after 2 weeks again, it grows another centimeter, so it's at 9. And then this way you could see the increase is 1 centimeter every 2 weeks. And so we could represent it using our graph. So at 0 weeks, the plant is at 6 centimeters. At 1 week, well, it would be at 6.5, but if we don't want to plot our decimals here, we could go over to 2 weeks, which it will be at 7. And then 3 weeks at 8, 4 weeks at 8, and then 6 weeks at 9 centimeters, and so on. And then if you see on our graph, if we continue here with the same pattern, at 8 weeks, it will be at 10 centimeters. At 9 weeks, it'll be here at 10.5. At 10 weeks, it'll be at 11 centimeters, and so on. So same thing using this graph. If I find the height that the plant grows and the time that it grows, you'll see that our point here, from here to here, increases by 1 centimeter in the span of 2 weeks. So if I were to pick another 2 points that were further away from each other, you'll notice that the plant grows 2 centimeters within 4 weeks. And you'll notice that 1 centimeter in 2 weeks is equivalent to 2 centimeters in 4 weeks, if you just simplify. So you could find the slope between any 2 points by drawing our triangle here and then seeing how much it rises up and the run. So our slope here would be 1 over 2, and our y-intercept is where this crosses the y-axis, which is at 6. So this is our y-intercept, which is 0, 6. And then our slope, again, just using any 2 points, we'll see how much it rises and runs, and then we'll simplify it if we have to. So in this case, if we had 2 over 4, we'd just simplify that to half. And that's it.